All right, now to continue on here, when two shapes are related by a scale factor, okay, they are called, and I'm going to use this word here, similar. Okay, so when two shapes are related by a scale factor, they are called similar. Okay, and I'm going to use my my nice little truck here again as an example. This truck is similar to one that is bigger, meaning that all of the dimensions of this truck have been scaled down to something a bit smaller, but they're all scaled down by the exact same value. Okay, so they're all scaled down by the exact same value. And I'm going to see, no, I don't see a scale factor on here. Sometimes they put a scale factor on. Maybe it's on the package that I got it with. Let's see. No, it doesn't say. It just says it's made in China. All right. Yeah, there we go. There's a little bit of a fun little humor, right? So when two shapes are considered, when they're related by a scale factor, meaning that all of their dimensions are changed by the same number, we call them similar. Okay? And that means is that each side of the shapes, okay, must be related by the exact same scale factor, and each corresponding angle, okay, must be equal. Okay, so if we have two, and we're going to look at 2D shapes in this case here, we can use 3D shapes as well. The angles must all be the exact same, and the sizes or the lengths of each side must be changed by the exact same factor. So let's take a look at a couple of examples here. It looks like my black pen's back, so we can use that again. Let's look at number 5 here. Are the following triangles similar? So we have this triangle here and this triangle here. Now, if we knew these angles, we could know if they were the same. If all the angles were exactly the same between each, okay, so this angle would be the same as that, this angle the same as that, this angle the same as that, then we know that it would be they would be similar. It's just that this one has been made smaller. But we don't know the angles, so we're going to have to use our dimensions. Now, are they similar? Well, this side and this side are related by some factor. Okay, and it all depends on which one we're going to use, and I'm going to call this the actual and this the scale. Okay, so that's the actual one, this is the scale one. You can use whichever one you want. You could do scale and actual if you want. Find the scale dimension, or scale factor. That's not a problem. But so we always do scale over actual. So 4 divided by 8 is equal to 1/2. Okay, and this equals the k from this side to this side. Now these two sides are also the exact same. It's also 1/2, 8 and 4. And the bottom has to be the same as well. So if we do 3 divided by 5, we get, well, 3/5, which is the same as 0.6. Now, 1/2 is different from 0.6. So what we can say is that these triangles are not similar because the scale factors are different. Okay, so the scale factors are different. You'll notice that between these two sides it's 1/2, and between these two sides it's 0.6. They're different, meaning that even though they look kind of the same, just made a little smaller, these two sides are not actually, put together properly, and so these are not similar triangles. They would have to all be exactly the same. Now, if we're told that two things are similar, we can recognize what the size of different pieces is going to be. Okay, so we're going to be told that the following shapes are similar, and we want to find the missing sides. Well, let's call this, and now again, it's always good to know what our actual is and what our scale model is. Now, these aren't drawn to scale, by the way, but just recognize that they are scale diagrams of each other. This is our actual, this is our scale. Okay, so if we know that our k value is our scale diagram divided by our actual dimension, dimension divided by actual dimension, we need to find two dimensions which are related. So the two sides that have the same orientation, okay, what are their lengths? And I'm going to use the tops here. So I'm going to use the 1 and the 3, 1 from the scale and the 3 from the actual. And so this is the k value. So our k value is 1/3, meaning that this one has a lengths that are 1/3 the size of this one here. So how we would find that then is, I mean, some of you might kind of recognize different ways of doing this as well, but if we want to find the scale dimension of, I'm going to use this side right here. Okay, so I'm going to use this as a question mark. The actual 6, what is the scale? Well, you might kind of have figured that out already. It's actual dimension times our k value, which is 1/3. So our scale dimension is 6 times 1/3, and that means that that scale dimension right there is 2. So this has a length of 2. Now, you might say, well, that's a really simple one. It's just 6 divided by 3. Yes, it is. I'm just showing you the method that we use to find that, as they do get a little more difficult, and sometimes their numbers are slightly more difficult there. So let's take a look at this side here. We want to try to find all the missing sides. This is our long bottom side. This is a long bottom side. We have the actual dimension. We need to find the scale. This times 1/3 gives us 4. Okay, and then we're given the scale here, and we don't know what the actual is here. But if we take, in this case here, if we want to find the actual dimension, we do scale dimension divided by k. And so our actual dimension is 1 divided by 1/3. Okay, and again, you may or may not be able to do this in your calculators. Let's try this out here. 1 divided by, and then it's 1/3, gives us a total of 3, which you might have kind of figured out already, okay, based on some of the other things that we see. So this side has to be 3, this side's 3, we know this side's 1, and then this side right here is going to be 3, and this will be a 9. Okay, that's based on the fact that this is 3 and that's 12, so that would have to be 9. This is 4, that's 1, that has to be 3. Okay, so there's a couple different ways that we can find the different sides. And again, we're using scale dimension to do that. Now, for this lesson right here, I want you to work on assignment, and here we'll put that up onto the screen. Number 3, questions 1 to 6. Okay, for that. And kind of work through each of those questions. And again, remember that our scale factor has to be exactly the same for all pieces of the between the model and the actual, and so they're all going to be the exact same number.